Thank you, Kay. Wow, this is a big crowd. This is the biggest Spark Summit event I've ever been to. I've never seen 4,000 people. So Reynold told you this morning about the story of how Spark started with Lester. I'm going to zoom out a little bit, and I'm also going to tell you the big picture of why we started the project, and then why we started Databricks. And I'm going to tell you about some challenges that we've been seeing in the market right now, struggles that people are having with AI. And I'm going to make 3 really exciting announcements of new things that we're launching here. But let's start with the story. So as you know, about a decade ago, we started the Apache Spark project. And what people don't know is that UC Berkeley is a public university, so funding for it has been decreasing over the years. However, the computer science department is actually really well funded. And the reason is that companies, tech companies in Silicon Valley, like Google, Amazon, Facebook, Twitter, they're actually investing a lot of money into these universities. So actually, our lab was really well funded. And at that time, we were Hadoop researchers. And we got a glimpse into what these companies were doing. It was around 2008, 2009. And it was super exciting projects. They had amassed huge amounts of data, and they built custom infrastructure, and they were doing machine learning on this data. And what was different from before was just the massive amount of data that they had and the things they were doing with that. So this was exciting for us, and we wanted to democratize that. We wanted to take those projects that we had seen, which were actually, we were under NDA. We wanted to take those and wanted to open source it and give it back to the community, so this community here. So we were super excited about that. And at that time, when we looked, there was a big divide between machine learning and data, or AI and data. Back then, people's data were locked into these data warehouses, and the data warehouses were not machine learning capable at all. So it looked very different from the tech companies. And on the other hand, we had these data scientists, but they were playing around with small data sets. They were using things like MATLAB or SPSS or Excel. So they were far behind. So we started the Apache Spark project. And the whole idea was to unify analytics. So unify the data and the machine learning in one engine. So you've heard all about this. So now you could, in one framework, do big data processing, do ETL, do SQL processing, do real-time processing. And you could combine it in your favorite data science languages, like R, Python, to do machine learning. So that was super exciting. And we had launched a project, and we were going around. I remember the co-founders and the rest of the people in the lab, we would get on 101 and go visit these companies, and we'd tell them, please take this technology. You know, Apache Spark, it does this, it unifies the analytics. And essentially, this slammed the door in our face. All of them just said, you know, this isn't enterprise ready. This is an academic project. What happens if the PhD student who wrote it finishes and decides to do something else with their lives? We can't do that. We can't depend our companies on this stuff. So in 2012-13, Andreessen Horowitz showed up, and they said, you know, what if we give you $14 million and you can start a company? And that was a lot of money for us. So we started thinking, and we said, wow, maybe we can actually have a chance to get this project out there and achieve that democratization if we have actually a company behind it. Because then people will have a throat to choke, and they'll trust that it's enterprise ready. So we started Databricks in 2013 with this goal. We wanted to do the same thing, just democratize this unified analytics, bring it out to the market. And we built what we called the Databricks Unified Analytics Platform, same name as Spark. At its core, the center was Spark, which provided you this unification of these two. But also, we decided to do it in the cloud, because we thought it's just too much hassle on-prem. People are just setting up these clusters, configuring them, getting them going. It takes 3-4 months. So we wanted to accelerate that. And we thought in the cloud, we could automate a lot of that. We know what the machines look like. We can configure the software. We can just get people started. If they want to try out some GPU machine, they can do that just in a few hours instead of going buying a whole cluster. So we were excited about that. And then on top of it, we also built some slick UIs because we thought it'll make it even easier to use. So we had notebooks and things of that sort so data scientists and data engineers could collaborate with each other. So we were super excited about that. That was now 5 years ago, actually. And now, if you look a decade later, since the inception of the project and 5 years after we started the Databricks, you look back and you look at what people are doing, companies are still struggling with ML. In some ways, actually, it's gotten worse. So you see a vast majority of companies super excited about the technology, but there's only 1% of them that are actually really successful. So it's the 1% of the companies that you hear about all the time in the news. The same companies that have these massive data sets, they have 30,000 engineers, many of them PhDs. Now they're also starting to take all the professors from the top universities. So they have a huge head start, and they're having these successes that we read about. The rest of Fortune 2000 is really struggling. And in fact, this divide still exists between the data and the machine learning in these organizations. In fact, we looked at the CIO survey that came out recently, where they asked enterprise companies, what is slowing AI innovation for you? And 95% of the respondents said that the silos of data is the biggest obstacle to the technology taking off. So that was the number one thing. Second, 90% of them said that the problem is that the data and the machine learning is separated. So it's siloed. So data engineering and data science is happening in different parts of the organization, and that's creating a lot of struggle. So it's making it very hard to get these projects off the ground. And then finally, they said it takes more than 7 months to go from idea to production. And that's self-reported, okay? So it's probably a year or something like that, okay? So these projects probably take years to go from idea to actual production. So what are the main obstacles? So over the last few years, we've been looking at the challenges people are having, and I want to summarize succinctly the 3 problems that we are seeing. The 3 problems that we are seeing, and then I'm going to tell you the 3 announcements that we have that address each of those, okay? So first, data is not ready for analytics. So great news is people have data lakes with lots of data in it, but the quality of the data is low. So there's a data quality problem that bites you later. Even if you fix the data quality problem, the second problem is that there's now a zoo of machine learning frameworks, lots of them, TensorFlow, PyTorch, Theano, there's a whole slew of these. And this is making it hard for enterprises because they need, again, they need that enterprise ready, something they can support for a decade to come. So this is also making it really hard. Okay, so if you overcome the second problem as well, you figure out how to navigate the zoo. The third problem is it's really hard to productionize machine learning. So it's one thing to have an idea and prototype it and get a proof of concept, but how do you actually move it into production? And that's the hardest part. So as a result of this, what we're seeing is that companies are actually saying, OK, this is so hard that we're going to take the first problem and maybe the second problem, we're going to give it to the data engineers, and we're going to separate these. We're going to have division of labor, and we're going to have specialization. So what we're seeing is that nowadays, we see a data engineering department being started in IT, and that sits in IT. So this is actually an example of 2 people that actually use Databricks Unified Analytics Platform. We have Wei Luo on the left. He's a data engineer. He sits in IT. And his responsibilities has to do with reliability, security, scalability. And he doesn't just let anyone get access to the data that he has. Okay, he's protective of that. And rightly so. And on the right-hand side, we have Brooke. Brooke, she's a data scientist. And she has all the mathematical thinking, the statistical models. She knows how to use the latest frameworks like TensorFlow. And she needs the data from Wei Luo. But there's this divide, right? Because he's saying, I'm not just going to give you this data. Okay? I mean, if I give it to you, who knows? You know, there might be a data breach, or you release it, and the company would be over. And she's saying, but you don't even understand the business here. I'm trying to advance line of business that I'm sitting in. And hence, there's this divide. And in fact, it's so bad that in some companies we've seen, not in this case, but in many cases what we've seen is that there's sort of a shadow data science emerging in IT, trying to take over the other department. Or there's a shadow data engineering with DevOps appearing inside of line of business. And this is being repeated in every line of business in big enterprises. So this is what's slowing down these projects. It's the politics between this. So it's a people, process, organization problem. It's not necessarily just the technology. But we want to solve it as much as we can with technology. So I have 3 announcements that I want to share with you that we're excited about. So let's go through each of them. So challenge number 1, as I said, was that the data is not ready for analytics. This is a data quality problem. And the reason for that is, so now good news is, all the enterprises have lots of data, and they've stored it in a data lake. That wasn't the case when we started the Apache Spark project. But now there is these massive data sets. It's been collected. It's sitting in the data lake. And the idea is to consume it downstream and do analytics on it, machine learning and other things. So what are the challenges with this? First challenge is, just because you dumped all your data into a data lake doesn't mean that you can just do analytics on it downstream. This data that's now sitting in the data lakes has inconsistent schema. The data quality isn't there. And it's very hard to do anything with it, especially at scale. Okay? Imagine you have a stream of data that you've been collecting for the last 3 years. And it's coming from devices. Well, maybe the firmware version of those devices changed throughout. And the data, in subtle ways, have changed its schema over this time. And now when you're trying to do analytics with it downstream, several years later, you're going to have problems. And you have to go back and iterate on it. And then, great, it's sitting in different departments also. So this is the problem with the data quality of the data lakes. Second problem is downstream when you try to build your applications, people are having a lot of performance issues. So especially if they want to do something in real time or if they want to combine real time and batch, what they're seeing is that it's very, very hard to do this in a timely manner, and it becomes really, really costly. Okay? So towards this, I'm super excited about Databricks Delta. That's going to be GA'd in a few weeks. Databricks Delta brings reliability and performance to your existing data lake and Spark. Okay? So how does that work? So the picture looks almost the same as before. You have your data lake sitting where it is, so it's great. You collected the data in it, that's great. Keep it there. On top of the lake, there are delta. And the analogy is kind of like rivers that are flowing or streaming out of your data lake into deltas. Okay? And then these deltas, what they do is they make sure that the data that's coming into the delta is high quality. Okay? How do you do that? On the entrance, it looks at it. You have to specify a schema for it. And you have to say, this data better look like exactly like this. And if the data does not look like that, Delta will just reject it and put it back into the data lake. And you can go look at it later and fix it, and then it can later enter the Delta. So it means data that is in Delta is high quality. We've checked the quality of it. It has a schema, and we're going to keep it pristine because we want to build applications on top of that. Okay? In addition to that, we've added transactions. This is an old idea from databases. We've added full transactions. So now your Spark data lake will get full transactions inside of Delta, which means as the data enters, if you have 10 terabytes that is coming in, we either insert all of it perfectly correctly, or we cancel the whole thing. You're not going to be left in transient state where some data made it into the data lake, some of it didn't, and it has inconsistent schema. So that's the most important part. So now that helps us advance the data quality problem that people are having with their data lakes with Databricks Delta. Second, downstream use cases. Now you can actually do things like reporting, dashboards, if you want to do alerting, or if you want to do machine learning, you can now do that because Delta, as the data is coming in, it actually caches everything, and it also caches the parts that are important, and also creates indices, keeps statistics of what it needs, so that downstream you can actually do really fast processing. So it's significantly more performant than if you were just operating on a data lake directly. And that actually helps, especially if you're doing real-time use cases where you want to combine real-time with batch. Okay? And I'm really excited. Right after me, actually, there's a keynote by Dom from Apple. And he's going to talk about how actually Apple in production is doing a massive scale project. And the exciting thing about this is they are basically processing a petabyte of new data that's coming in to do threat analysis and machine learning on top of their data lake using Databricks Delta. So that's super exciting. And then you're going to have Michael Armbrust, who actually created Delta at Databricks. He worked actually closely with Dom, so he's actually going to get on stage and actually demo how it works so that you actually understand the inner guts of it. So OK, so that's the first thing, and that's the thing I'm the most excited about, to be honest with you. This, I think since we started Databricks, it's probably the biggest innovation that I've seen, at least inside our company, is Databricks Delta. OK, but that was challenge number one. Challenge number two, there's a whole zoo of frameworks now that is appearing out there. You might have seen them. There are things like just machine learning frameworks. These machine learning frameworks like scikit-learn, MLlib, Spark, H2O, that's just machine learning, basic machine learning. Then there's a whole explosion of the deep learning frameworks. Deep learning frameworks like TensorFlow, Keras, Caffe, Theano, Big Deal. And then we have things like just libraries that people need, Python, R, Anaconda, NumPy, SciPy. And then there's serving and monitoring for production. And there isn't as much, but things are appearing. So things like MLeap, TF serving, Azure ML. But also, a lot of people are just building their own serving infrastructure, just customized on top of NoSQL stores. So they'll use a Cassandra or a Redis, and they just build it on top of that. OK, so the problem with this is now you have these data scientists in line of business, and they want to use the best tool here. And the reason they have to use the best one, this is different from previous decades. Previous decade, you pick the best data warehouse, and you settle on that, and then you use it for 10 years. Machine learning is different. In machine learning, you want the best result for each use case. That 2% accuracy improvement actually matters. That could save you $10, $20, $50 million for your business. So you want the best one for each use case that you're doing. So rightly so, all the data scientists, they always want to pick the latest thing that is coming out. And there's one release every month. Okay? So towards that, what we're announcing today is Databricks Runtime for Machine Learning. Databricks Runtime for Machine Learning is basically a team that's dedicated inside Databricks to just integrate, compile, and optimize clusters that just work out of the box with all the tools that you need. So hence, people in line of business no longer have to spend their time. The Brooks of the world don't need to install, figure out the dependency that's going on, and making sure that it's compiled for the right machines, because each of these frameworks, like TensorFlow, it has CUDA libraries that have to be specially optimized for the particular machine that you're running on. If you have a particular GPU machine, if you have a Tesla P100, it's different from P80. So this is all integrated. It just works out of the box. So it saves a lot of time for those data scientists who want to use machine learning frameworks. OK, and then third problem, how do we productionize machine learning? This is the hardest part. And the problem is, basically, the machine learning lifecycle goes from data prep, which typically happens by data engineers, again, sitting in IT often, then moves over to data scientists like Brooke. She's building the statistical models. And actually, the secret is, to get to production, you probably build 100 iterations of that model. So you don't just build one. You're building lots of iterations of those. And each of the iterations, you have to go between IT and then back to line of business. And then to move it into production, it's usually re-implemented from scratch again by someone else, typically, actually, in IT, that moves it into that reliable, secure place. Okay? So we're announcing today a really exciting new open source project. It's called MLflow, Machine Learning Flow. And it basically helps you move between data prep, building models, and deploying models. It makes reproducibility really easy for all these frameworks that are out there. So it integrates with all the open source frameworks that are out there, things like TensorFlow and scikit-learn. It just integrates with those. And it enables you to track exactly the results that you're having there. So I'm not going to steal the thunder of this. The creator of Spark actually is also the creator of MLflow. So he's going to get on stage, just last keynote here today in this session. So please attend that. He'll talk about how it's built, and he'll also do a demo. And this is fully open source, so we're hoping that we can build a strong community around this. OK, so all this, we've put it together. It, of course, comes in the Unified Analytics platform. At the bottom, we have the cloud service. We still believe firmly in the cloud. It's now fully integrated into Azure. So Microsoft is now offering this. So this is a Microsoft service. It's called Microsoft Azure Databricks. And it's first-party service integrated with all the things that they have in the ecosystem. So I'm very excited about that. And it also works on Amazon, where we've been available for the last 5 years. On top of it is the Databricks runtime. Databricks runtime comes with Delta that I mentioned. It also comes with that machine learning runtime that makes it easier for you to just use whatever machine learning library you want to use. And then on top of that, we have the workspace with the UIs, the notebooks. But we'll also integrate in there MLflow, which enables you to do the reproducibility and moving it into production. So this is awesome. And actually, what we're seeing is the companies that are really successful with this, they're actually starting to reorganize. What they're doing is, oftentimes, we're seeing the really successful companies, they're having a center of excellence. They'll have a center of excellence on data science. And they'll typically have one person in charge of it. So they'll have a chief data officer. And that way, they can get around the politics. And if they don't want to reorg, they'll create a matrix org, which has the center of excellence, which sort of cuts across the line of business and IT. So this is super important. But for that, they also need the technology. If the technology is completely disparate, it's going to be very hard. So we're hoping that with the Unified Analytics platform, we can make that easier so that at least it's integrated end-to-end between all the way from the data prep to the production. So we're excited about that. It's now being used by lots of enterprise companies. You see some of the logos here. And in all these cases, our goal is to make data scientists and data engineers like you that are in the audience the heroes of your organization. We want to make you much more productive in what you're doing. And my last slide, I want to talk a little bit about the customer keynotes that are coming up here today that are very exciting. First, I told you about Dom from Apple. He'll talk about this massive scale that they're working on. Then we have John Gohl from Capital One. He's going to talk about how they use unified analytics to get the data scientists and the data engineers at Capital One to be much more productive. We have Chris Robinson from Overstock, who's going to talk about the personalization of the whole digital experience at Overstock. And after that, we have Justin Lido. He has a really interesting use case. He has these massive billion-dollar construction projects, and he's optimizing them and making them more cost-effective using deep learning on Databricks Unified Analytics platform. And then finally, the thing that actually gets me up in the morning and many of the other Databricks employees is what Regeneron and Dr. Jeff Reed is doing. So what he's doing is he's actually fighting diseases like cancer and cardiovascular disease. And the way they do that is by doing genomics on top of Databricks. So they get the genes. They can actually figure out which genomes are responsible for which diseases, and they can create drugs that can fight these diseases. That's my last slide, so thank you.